In the last video, I talked about the difference between classes and structs. Now in C# 9, we got a brand new base type called record, and in C# 10, another one called Record Struct. You might be wondering why, after almost 20 years, do we need some new base types? And honestly, maybe we didn't, but they are kind of cool, and you should know about them. So in this video, I'm going to go over the new record types. So as far as I can tell, the only difference between a class and a record is how equality testing is handled. So what do we mean by equality testing? So here we have a class that you may recognize from the last video on classes versus structs. And now let's create a couple of these. So let's make a class called C1, and we'll initialize the number to 5, and we'll set our flag equal to false. And let's make another identical one, and we'll call it C2. And we'll do some equality testing. So if C1 equals C2, then we'll write one message. Otherwise, we'll write another message. So why don't we say if they're equal, we can do console.writeLine, they are equal. And if they are not equal, we'll say they are not equal. Let's run this code and see what we get. F5, and they are not equal. So what's going on here? I mean, they kind of look equal. So by analogy, imagine you had two cars, and the two cars have the same make, the same model, the same year, the same color, the same upholstery, the exact same mileage, the same amount of gas in the tank. In fact, every property about the cars was the same. However, they are still two cars. It's not right to say that they're the same car. They're two cars that just happen to be identical. So by default, this equality test doesn't really ask if they're identical. It asks if they are the same instance. Now, we could write a function. Let's try this. We can say public static bool are they identical, where we pass in a class and another class, and then we would have to write some test code. So for example, we could say if C1 is not null and C2 is not null, then we would return C1.number equals C2.number and C1.flag equals C2.flag. And then our default can be, oh, I missed an equal sign there. And our default can be no, false. So now we could change this and say if class dot are they identical, C1 and C2. Now let's see what that returns. C2. Okay, let's run that. So now it says they are equal. So those are the two meanings. One is instance identity. The other is sometimes called value-based identity. So if you are interested in value-based identity, this is one approach, is just to create this kind of function. But another approach, which is kind of nice, and this takes a bit of code, so I'm going to copy and paste it from my other screen here instead of typing it all. So another approach is to override the virtual equality operator that is part of the base object class. And then you can write some code like, okay, if the one that we're testing against is null, that's a false. And if the one that we're testing against isn't the correct type, that's false. And then we can do our test for this versus other. Now, when you do this, it's also standard to override the equals and not equals operators. So now we've really changed the meaning of equals equals. So let's go back here and let's put this back to the way it was, where if C1 equals C2, then are they equal? So let's run that code and see if it works. Hopefully it compiles. And now they are equal. So what we've done is we've changed the meaning of equality. And instead of instance equality, we're doing value-based equality. Essentially, in plain English, we've said that they are identical. So this takes quite a bit of code to do. And you would have to write it for every single class unless you wanted to do some reflection-based thing, which would not be efficient. So this is where a record comes in. So let's declare a record type. Public record, a record, and we'll give it the same fields. And now we'll change our test. So instead of creating a class, we'll create a record, and let's just call it R1. And we'll create another record, and that is R2. And now we'll change this to R1 versus R2. So will they be equal or not? Let's run it and see. And it says they are equal. And just to really prove the point, let's go ahead and change one of the properties. So now R2's number is 7. And if we run that, it should say they are not equal. So basically what the record gives you is all of this equality testing code for free. And now a record struct is exactly the same thing, except the base is the value type, a struct. So in closing, I just want to mention I have seen some articles and other information online that said that records are immutable, not changeable. And that's not true. You can absolutely change a record. I can write code here where I can say r1.number equals 100, and it lets you do it. You can mark your records as read-only, just as I showed you in the last video with structs, and that's a fine practice, but there is nothing inherently immutable about record types. What they give you, pure and simple, is this other way of testing equality. So there you go, the new C# record types.